Jane drives from home to the train station at an average speed of 30 miles per hour. She boards the train immediately and travels to her destination at an average speed of 60 miles per hour. The total distance that Jane travels is 150 miles. She reaches her destination after 3 hours of travel. What is the distance from the train station to her destination? First, we need to organize the data that we have. So we know that there are two different distances, and we know that one distance is covered at 30 miles per hour. So I'll call that D1. I'll say D1 is 30 miles per hour times T1 hours. Be careful to write the units. D2 is going to be 60 miles per hour times T2 hours. You can rearrange these at this point if you want to and say that T1 is equal to D1 over 30, and likewise T2 is D2 over 60. We're also told the total distance that Jane travels is 150 miles, so that's going to be D1 plus D2 is 150 miles. We can also say that the total time, so that's T1 plus T2, is 3 hours. All right, and we can make these two things correspond to each other because we know what the relationship between T1 and D1 is. We know what the relationship between T2 and D2 is. So what I'm going to start with is the T's here. I'm just going to put in D1 over 30 and D2 over 60 here. So D1 over 30 plus D2 over 60 is equal to 3. I can multiply both sides of this by 60. So that's going to give me 2D1 plus D2 equals 180. All right, now I have two equations that look very similar that I can make correspond. So if I get D1 plus D2 is 150, and I get 2D1 plus D2 is 180. All I have to do is change the signs on one of them. Given the circumstances, it's going to be easier to change the signs at the top. So basically I'm multiplying by -1, which means I flip all the signs here and then add them, which gives me D1 is equal to 30, which would imply then that D2, which is actually the distance from the train station to the destination, is 120, because we know that it's 150 total.